As I indicated, I'm Cory Franzmeier, and I run the cloud platform business for Google for Asia Pacific. And as I tell my peers that run the US and EMEA, I actually run our business for the other half of the world. So pretty big responsibility there. While we work on the slides, Google was founded 15 years ago on the idea that we wanted to organize the world's information and make it universally accessible and useful to everybody. That's a simple problem statement for sure. And over the years, we've included things like user-generated video content, mapping information. We've included now social information into all of that. And we've really worked very hard to make this experience the simplest experience for our users as possible worldwide, to make the latency and the speed of Google disappear for our users. And while that is also a set of simple statements, it really makes it into a computer science problem, because it's really not that easy to build the google.com website and keep it up 24 hours a day and make the average response time under 60 milliseconds worldwide. And so what we've had to do is build the world's largest Google computer. Google invests nearly $3 billion every single year building our own hardware. We build our own storage subsystems. We build our own network equipment. We have our own private fiber networks that connect all of our data centers together in one big Google network. And then we have private fiber connectivity to nearly all the tier 1 internet access points around the world. And that technology is what makes Google so fast. But anybody could probably spend a couple $1 billion a year just buying hardware and stuff like that. Your CFO isn't going to be happy with you, and your investors, might want to know a little bit more about your business plan. But that's actually a really easy thing to do, is spend $3 billion. Pretty easy. What's not easy to do is optimize how you take advantage of all of that hardware. And so over the years, we've had to invent a lot of software. One of the very first problems we ran into is there were no suitable file systems for Google to live on. So we built what we then called the Google File System. We wrote a white paper on that and released it to the community, and that eventually became the basis for the Hadoop distributed file system. It wasn't long after that we needed to start answering questions like, how well were our servers performing? How do we optimize network packets across this vast network? How do we identify and trend the top searches? And database technology at the time just wouldn't scale for that. Uh-oh. So we had to go back to the drawing board again. And we built a product called MapReduce. Now, MapReduce is a technology for large distributed file processing. And it's really composed of 3 steps: a mapping function, the easiest step, which is the shuffle. Actually, that one's kind of trivial. And then the reduce. And so we had to build this framework so that we could just answer simple questions across millions of computers and millions of searches. And it's a great technology. We wrote a white paper on that as well, and that got released eventually as, or taken up by the open source community as Hadoop. And now there's been a whole industry sparked around big data from these 2 activities alone. And people like Twitter and Facebook, and you'll hear from Cloudera a little bit soon in a few moments, They've taken all of this great technology as a starting place and done even greater things with it. But MapReduce is, at its core, a computer science program. And it's a batch-oriented computer science program. And what we found is that really wasn't enough to answer all the questions that we were asking as a business. If you wanted to know what were the top 10 search strings globally, that was an easy MapReduce question. But then if you wanted to say, well, what were the top 10 MapReduce or queries in Korea? Well, that's another MapReduce program that somebody has to write. And so quickly you get down to having to write a new program for every single ad hoc query you want to execute. So it really wasn't possible to do interactive ad hoc analysis across terabyte-sized data sets with MapReduce. We also found that not every programmer and business analyst wanted to learn how to write MapReduce programs. Not all of them are, master's degree computer science individuals. A lot of them just want to ask a question in a language that they already understand, and that's SQL. So the tools that they were using generated SQL. The language that they were programming in, the query language was SQL, and so they needed that access. Then what we found out is that, scaling these systems to terabytes and terabytes, petabytes even, was really hard. And finally, that the teams inside Google just wanted their analytic platform to be a service. They didn't want to have to set up databases and handle indexes or anything like that. All they wanted to do was put their data somewhere and ask questions. So we had to invent another database technology. This time we invented a product called Dremel. Now, Dremel has also been released as a white paper, and there's various flavors out there floating around. Drill is one of them from the Apache group. What it does is it takes record-oriented information, so row-column-oriented information, and creates a columnar database out of it. And what that lets us do is spread those columns out over thousands of computers and hard disks. And then we get some great compression on that as well, because it's all the same data type. And we can launch thousands, tens of thousands of individual threads to spider down those columns and return information very, very quickly. And then what we did is we just put a query engine over the top in SQL. So we created this great database called Dremel, which we've now made into a product called BigQuery. And what it does is it simply lets you upload row-column-oriented information in a CSV file and then ask questions in SQL. And it scales to terabyte-sized data sets and returns those queries in seconds. And most importantly, even as the data size grows underneath, the query response times are the same. So you don't have to worry about, outgrowing this service. So what are some of our customers doing in this environment? So YouVersion is a Bible reading application out of the United States. It's used by hundreds of millions of people around the world. It's published on virtually every computing platform known to man. And it generates over 100 billion rows of information about how people read the Bible, how they engage in study plans, and all this information about how people use this product. And so they use BigQuery to get information and help content publishers of Bible study plans, understand who's using their product, how are they using it, do they continue through their study plan, and it's very, very simple and easy for them to use. They actually only have 2 people that manage this infrastructure, that write all the queries and upload all the data. Pretty amazing for 100 billion rows, and growing. And MapR was able to take, they have their own custom Hadoop implementation, They were able to take that onto the Google Cloud Platform, and they broke the TerraSort world record this year. And they did that in about 54 seconds. So for those who don't know what the TerraSort record is, benchmark is, you take a terabyte of randomly generated information and you try and sort it as quickly as possible. That's the benchmark. So the prior benchmark was about 1:06. They got it down to 54 seconds. But I think the most interesting thing is they only spent $700. The prior record was an on-premise system that cost nearly $1 million. And that's amazing capabilities. In fact, I think it's so interesting that I thought maybe we might take a look at the record itself. Now, it goes fairly quickly. So before we get going on it, it goes really quickly. Now, this is 1,003 nodes on Google Compute Engine. This is a heat map on the left-hand side. Green is sort of busy, yellow is pretty busy, and red indicates flat out. So what you're going to see in 54 seconds, and it goes really quickly, you're going to see the map, and then the reduce, and then we're done. Okay, ready? So you guys can time it if you want to. Here we go. So here, we're kicking it off right now. You can see the cluster start to warm up. We're at 59% of the map so far, and now we're going to go into the reduce. And we're, 30 seconds into it now? We're almost halfway done. We'll be done here in another second. The cluster's running, getting all our results, cleaning up everything, and now we're finished. That's a world record right there. Thank you. That's pretty amazing, $700. They went on to break the minute sort record, which is how much data can you sort in 1 minute, and they spent about $200 on that one. So this is some amazing capability that Google's bringing to the marketplace. So how are we helping people do big data analytics on Google Cloud Platform? We have a whole range of services on the Google Cloud Platform. We have a set of computational services, a set of storage services, and a set of higher-level application services. And people compose these in various flavors to create a complete solution. So for those who don't know what we do in this space, I'm going to just take a couple moments and walk through what these services are. Google Compute Engine is our infrastructure as a service offering. This is Linux virtual machines, your own global private network, and various flavors of storage so that you can create very custom, highly complex software environments, not unlike what MapR just did. App Engine is our platform as a service offering. In this case, you write applications in Java, Python, or PHP. You use our APIs, and you deploy that to Google. And when you do that, Google takes care of everything. We set up all the networks, all the firewalling, we handle all the DBA, all the sysadmin, everything. All you do is write some code and manage policies around that code. On the storage front, we have Google Cloud Storage. Cloud Storage is our object-based storage environment. You get a little slice of the Google storage infrastructure, the very same infrastructure that supports YouTube. You can put as many digital objects in it as you want, and they can be as big as 5 terabytes. So you can really start to create some really interesting storage architectures for your applications. We have 2 managed database offerings. Google Cloud SQL is our MySQL managed service offering. So it's a completely managed MySQL instance by Google. We've taken care of the data store replication under the covers, so you even get some disaster recovery in that. And so your sysadmin or your DBAs can use it exactly the same way as they use MySQL today. And finally, Cloud Data Store is our NoSQL database. This is actually the native database underneath App Engine. but we've broken it out so now you can use it in your own custom applications as well. This is one of the largest NoSQL instances in the world. It supports about 5 trillion data store activities every single month. For application services, inside App Engine, we have queues and caches and everything a developer needs to build a real application. And then we've built a couple other services that I think are pretty interesting and unique. One is cloud endpoints, and we'll probably talk about this a little bit more later, but if you're looking at online and offline and mobile, cloud endpoints is really going to help you. It really helps you create a single API layer for all of your business logic, and then automatically generates client libraries for JavaScript, iOS, and Android. So you can really just focus on that user experience on the native mobile device. And then we talked about Google BigQuery. So again, this is our fully managed big data analytics as a service offering. You upload information in row column format and ask questions in SQL. And so people compose these services together to make solutions. We have a total solution from ingestion to processing, transformation, analytics, as well as great partnerships to help you visualize and share all this information. So if you sort of go down one stack from the architecture slide, there's a various ways to compose storage. We have the ability to capture and store your log-based information. With Cloud SQL or Data Store, we can capture all of your structured information, and Google Cloud Storage allows you to submit all your completely unstructured information. And a lot of people are building data pipelines over in either App Engine or Compute Engine, depending on what level of technology they want to write code at. So they can do things like transformations. They can even do very deep statistical analysis with, say, R or something like that on Compute Engine. We recently released a Hadoop framework for Compute Engine. So you can go to our website and download a completely pre-built configuration for running Hadoop on Compute Engine. You can also get it from GitHub. They then push a lot of that information directly into Google BigQuery, where they're able to use some tools. We have partnerships with companies like Tableau, ClickView, BIM Analytics for BI tools, so you can create dashboards that interact natively with BigQuery. We have customers that use Google Apps Script or even Microsoft Excel to integrate spreadsheets into queries on BigQuery. And then we have a large number of customers that write their own front ends on App Engine. So you can really compose a total solution: data pipelines, storage, archival, and analysis and querying. So what are some of our customer use cases? A great customer story comes from GameSys, and they actually presented at Google I/O. So GameSys has a lot of games, but one of their newest games is Here Be Monsters. And this game is actually just about to be fully released. It's still in beta, but they have lots of users. They have about 10,000 daily active users on this game that generate approximately 200 million events every single day. So these are purchases, they're activities inside the game, who they're playing against, all that stuff. They log all of that information so they can optimize the gameplay environment. So every night, they run some code inside their game, and they extract all the relevant information and put that in Google Cloud Storage, and then upload it into BigQuery. So that happens every single night. Now they have some set reports that they distribute to their marketers, their platform engineers, their CFO, who's really interested in how much money they made, their CEO, and they distribute all of that through Google Spreadsheets. So they use Google Apps Script There's a working demo out on developers.google.com for this. Very, very simple. Actually, I used it in a demo a couple weeks ago, so if I can use it, you guys can definitely use it. And they build all their reporting, their kind of day-to-day reporting on Google Spreadsheets. They then built a custom app called Mailman on App Engine. So App Engine gets information from BigQuery, and then they use the information in that to try and retain users. So they can do things like, hey, Cory, you haven't been in the game in the past, 72 hours, but your friends have been. Maybe you'd like to come back and join them. And they've wired up App Engine to email, to the Google messaging service for Android, to the iOS Apple Push network, and then also to Facebook. So whatever their game players tell them how they want to be contacted, they've already put that into Mailman. And now they're actually taking it one step further. They've built a system that they call Cobra. And Cobra is intended to be a real-time offer system. So it's actually completely integrated back into the game itself, and it's integrated with the various in-app purchase mechanisms. So Google Play Store, the App Store from Apple, Kakao is one of the other ones, and a couple of the others. So what they do is they use another tool from Google called Prediction API. And Prediction API is basically about 12 machine learning algorithms wrapped up into a service for you. It's dead simple to use. You simply provide a training set. We pick the correct machine learning algorithm to match that training set, and then you just ask questions of it, and we give you a probabilistic answer. Now, if you had to set this up on your own, it'd take you months or years, but Prediction API is dead simple. And so what they can do is they can predict what their customers are doing inside their game on a real-time basis. And then they can present them offers. Hey, it looks like you're struggling with level 15. If you bought this type of sword, that might help you progress to the next level. So they've built a whole ecosystem on Google Cloud Platform to help them analyze their gameplay first, and then now to really optimize their revenue stream, all on top of Google. And they did that because they wanted the scalability capabilities of Google. In another sector, we're working with an insurance company. And they're actually taking telemetry information from the car so that they can analyze how well you drive. So they can actually give you a customized quote on your insurance. So they have thousands and soon to be millions of these devices in cars generating information about how fast you drive, when you drive, what kind of traffic do you drive in. And so they need to collect a lot of events from that environment. And they collect that and they put that on Compute Engine, where they transform it into a sort of canonical format that they can then analyze in Google BigQuery. And they use the product from Tableau to actually build all of the dashboards. In fact, the IT team, the developers, they're not even involved in the construction of the dashboards themselves. The business users construct the dashboards using Tableau. And that integration back to BigQuery makes it possible to kind of remove the step of even having to interact with IT, which is really, really powerful for this company. And finally, another company, Cdiscount. So Cdiscount is the largest online retailer in France. And what they wanted to do is build a recommendation engine. So they wanted to say, hey, Cory, you just bought Car Magazine. All of your friends also bought Bicycling Magazine. Maybe you should consider that. So their current on-premise data warehouse couldn't do that for them. It's just too hard for that environment, and they generated too much information. So they came to Google and a partner of ours, MapR, and they said, hey, can you help us with this problem? So we went through a proof of concept with them. So they're running MapR's Hadoop distribution on top of Compute Engine. They've put in all of their rules into the MapR engine. And they found that Google Compute Engine with MapR was 15 times faster than their on-premise data warehouse, which was a traditional relational database. So they've really been able to create this great recommendation engine for their business. They've saved a lot of money doing it, and then also sped up that entire process. So some great customer use cases as you sort of think about all of this. So customers are coming to Google to do all of this because they want to do a couple things. They want to reduce the time and effort to do big data. And they look at tools like BigQuery, which is a service. They look at that as a very low cost, low effort way to analyze very, very large data sets. They come to the rest of our platform to create complete pipelines. They don't spend any money up front. There's no capital cost up front. And they're finding that their ongoing operating costs are dramatically lower than their other alternatives. And that's really what we're here to help companies do. Get started with new ideas at a very low entry point, and then if they're successful, you can scale on this platform going forward. So lastly, I wanted to wrap on something that I think everyone likes, which is something free. We have, I'm announcing today, the starter pack on Cloud Platform. So it's $2,000 US. It's a credit. What you do is you go to cloud.google.com/starterpack, and I don't see quite enough cameras out there for more mobile phones than there are Koreans. But go to this, you fill in some information, you start up a project on Google, you enter in my code, please use my code, and then we'll get you a $2,000 credit for starting to use our platform. And it's really a great way for you to come experiment with Google Cloud Platform and to gain some experience with what I think a lot of people think is a great platform. So that's all I had today. I really appreciate everyone paying attention. I do love coming to Seoul, so if you want me to come back, please send me an email, and I'd love to come back. So, Kasamada.